I'm Paul Tompkins, the Kelp Restoration Coordinator for the Nature Conservancy Australia, and I'll be presenting with Simon Branigan, he's the Marine Restoration Specialist. I'm going to tell you guys a little bit of a story about giant kelp, about underwater forests in Australia, and unfortunately, it's a bit of another shifting baseline story, similar to the seal story that we heard before. Australia has had underwater forests of a species called Macrocystis pyrifera, giant kelp, which can grow to over 40 meters long and reach the surface. And Simon's going to speak to a little bit about the importance of those. But we know that these were culturally important for tens of thousands of years for traditional owners. In Tasmania in particular, sea country was women country. Women were the divers. They were diving in kelp forest, catching abalone and lobsters. But due to the history, unfortunately, a lot of that knowledge has been lost. And we're reliant on other sources of information to tell us the ecological history of giant kelp forests in Australia. One of those pieces of information comes from Admiralty charts from the 1800s. The British Admiralty were really worried about creating accurate charts, mostly for identifying hazards to navigation. They would notice these large abundance of floating seaweeds in deep water. This is in more than 10 meters of water. And they would chart these as accurately as possible on their charts. We can go back and look at these charts, georeference them, create polygons of the what we assume are kelp forests that they had mapped out, compare those to more recent surveys, and realize that this 95% loss number, which you may have or may not have heard before, may be a radically shifted baseline. Chances are there was heaps more giant kelp historically than we ever realized. There are persistent patches of giant kelp around Australia and Tasmania, but also in Victoria. Victoria's had underwater forests at least for the past few decades. Unfortunately, there's anecdotal evidence from fishermen, from divers, from these older generations of water people showing that they started to disappear a few decades ago, probably around the 50s, 60s, and even 1970s. For example, there were forests in the rips at the mouth of Port Phillip Bay, rather large and dense forests of giant kelp, which younger generations have never seen, would never know existed because they completely disappeared. But there are, again, in Victoria, there are persistent patches of giant kelp typically in semi-protected shallow reef systems. But again, this is a shifted ecological baseline that we're trying to identify and use as a baseline for recovery and for restoration. Simon's going to jump in and show you a little video.
So we've been producing a series of videos called Kelp Chronicles that document our work, mainly in Palawa in Tasmania, but also Victoria as well. So this is a bit of a sneak peek. We won't show this full video. This is only for a couple of minutes. PT is usually the star of the show. He's not in this one, so he's a little bit salty about that. But there is a familiar face.
That's Lonsdale Reef, and the PM Reef is over there, and the kelp was on the Queenscliff Port Lonsdale side in the bight.
Giant kelp forests are one of the physically largest marine biogenic habitats. They are incredibly important as nursery grounds for a number of different species, rock lobsters, abalone, a number of different fish species.
It was like a tea tree forest, but kelp underwater. As far as you could see, it was slack water. It was just all standing up like a forest. It wasn't something we sort of consciously noticed, but then a few years later we thought, there's no kelp coming to the surface anymore. I reckon that probably disappeared early 80s, I reckon.
I grew up on Cape Otway, and so I had a fair bit of experience in some of the bays crawling through giant kelp, I guess, looking for crays in a couple of the places where it grew pretty thick.
The cover and abundance of giant kelp has been disappearing over the years from climate change, and catchment of coast type pressures.
I spent a bit of time away from the Otways. When I was studying, it sort of just twigged to me how different some of the places where I used to expect to force my way through giant kelp forests. It was just completely open.
You know how to cultivate giant kelp. We're really at a point where we're ready to go to scale. We're ready to sort of have industrial scale restoration of giant kelp.
My daughter's mad on the ocean, so I'm really hoping that she'll get into snorkeling like I did. As you know, we are losing things across the world, and I hope that giant kelp is one of those systems she'll get an opportunity to see and crawl across like I had the chance to.
So as sort of already highlighted, the loss of kelp isn't exclusive to Victoria. There's been a global loss of kelp. There's a number of different drivers through that, through climate change, such as warming seawaters, heat waves, pollution, and over-harvesting as well. So just a bit of a global picture, but we've got some good news coming in a sec. There is a number of really critical ecosystem services that giant kelp macrocystis can provide, incredibly important in terms of fisheries, particularly for abalone and crayfish, tourism. Tasmania for many years was a hotspot in terms of tourism for giant kelp diving. Tourists will ask to dive in giant kelp in Tasmania, but it's quite limited these days. It's a nursery habitat for a number of different species. Giant kelp is quite a prolific grower, can grow up to sort of 0.5 metre a day and over 30 metres in height. So it requires a lot of nutrients in order to be able to do that. And also once the holdfasts break off from the seabed, those nutrients are then transported to other parts of the ocean. And also giant kelp can help buffer coastlines by dampening the wave energy. So buffer coastlines from coastal erosion.
So as part of our work with giant kelp and trying to create baselines for at least its current distribution, we wrangled an agreement with Planet Labs. They have a satellite array and they have imagery at 3-meter resolution of the entire surface of the planet. And they gave us a data set of that imagery. In time, it runs from 2016 to 2023. And in space, it covers the entire theoretical distribution of giant kelp in Australia. That is from the South Australian coastline around Robe or Cape Jaffa, all the way around to the southern New South Wales coast around Tathra, and includes all the Bass Strait Islands and all of Tasmania as well. So we were fortunate enough to get some support from Google Australia and a geospatial company based in Perth called NGIS to help analyze this imagery. And we've developed some AI, some artificial intelligence, for better or for worse, to help identify or detect giant kelp canopy on the surface of that imagery. A lot went into this. There are a lot of caveats, a lot of work, a lot of nuts and bolts and mechanics, which I am more than happy to go into the details in later if you have any questions. I'm happy to jump into the deep end, so to speak. Long story short is that we're preparing to launch the products of this analysis onto CMAP Australia. They will be open source, available to the public, and there will be a feedback form. If you see something that looks a little bit weird on the mapping, please let us know so we can adjust it, we can make it better. It's a model, it's not perfect, but we do want it to be as accurate as possible. Obviously, this covers the Otway Coast. We have had some detections, which we've confirmed. Simon and company and Jack were out there identifying a patch of kelp around Crayfish Bay, for example, which this image shows. You can see we've broken up the detections into nearshore, which is the blue polygons, near coast or estuary embayment vegetation, and offshore. The reason being is that there may be some other off-target species like Eclonia, Philospora, Dervilia in nearshore that you can't distinguish from giant kelp, and we have higher confidence that the offshore detections 5 meters and deeper water is actually giant kelp, so we kept them separate. if you were to open the map layer and click on a polygon, it would tell you the size of the polygon, the year it was detected, et cetera, et cetera. So again, this will go live this week, which we're pretty excited about. In the background, we've been working for a couple years on a restoration project in Tasmania. In 2023 and 24, we ran very, very small scale giant kelp outplantings at 16 different sites up and down the East Coast, from St. Helens all the way down to South Bruny Island. Monitored those at 3-month intervals. We had some really good success in the face of the marine heat wave that hit the coast in 2023-24. We did get giant kelp to grow to a significant size in just a few months there. So what we did is 2 monitoring events at each site at 3 and 6 month intervals. We took the data and use that to choose the best performing sites for larger scale work. And we're really fortunate that Scott Ling at University of Tasmania was able to get a grant from the federal government as part of their priority place, Saving Native Species Priority Place scheme, to support a much, much larger body of work than we would have been able to do otherwise. His project is titled Improving the Ecological Conditions for Giant Kelp. It's a 7-pronged approach, which includes things like transplantation of southern rock lobster, urchin management, recreational dive involvement, et cetera, including the Nature Conservancy as a primary partner. And it's complementary to the work that CSIRO is doing with genetics, which I can get into later as well. Long story short, with this funding and in partnership, we were able to engage the commercial diving community in the outplanting for this year. So we took it to scales which otherwise would have been completely unattainable. We used that data from the trial sites to pick the best performing sites. Now we're into monitoring. We just wrapped up our outplanting about 2 weeks ago.
Just in terms of the bigger picture, giant kelp was listed as a threatened ecological community back in 2012. DQ are now considering sort of updating that conservation advice. They held a number of workshops in Hobart that people from the mainland also sort of zoomed into. TNC and UTAS and a bunch of other subject matter experts compiled a white paper and provided recommendations for this process as well. And just a quick plug for this, we're also working on a Colonia radiata, golden kelp in Port Phillip Bay. Our colleague Scott Breshkin's leading this. Some really exciting results. This is also in collaboration with University of Melbourne, Deakin University and Parks Victoria. So the driver of the change here is sort of the purple urchins, which is predating on the kelp. And very quickly, those that aren't familiar with who the Nature Conservancy are, we're a global not-for-profit organisation, touchdown in over 70 countries worldwide, and work in both sort of ocean and also in the terrestrial space. And thank you very much.
Timing, mate. Thanks, fellas. I find that kind of uplifting. Have you seen my beanie? Because that was the last place I saw it. No? Okay.
Jared Ward asking.
Questions for these fellas? Have any of you seen my beanie? Up the back, one down the front, and then up the back.
Just a quick one. The involvement of the local ab divers in your work. I think you worked in conjunction with the local fisheries ab divers.
We mostly work with the Tasmanian Commercial Divers Association, TCDA. And some of them hold ab licenses, some of them hold urchin licenses, some of them hold both. Does that answer your question? Oh, okay. Yeah, we've got about 12 guys on the register. They're paid through Seafood Industry Tasmania, but we do all the coordination work, tell them where to go, when to go, and provide them with the juvenile kelp to outplant. It's been a great experience working with those guys. They're really motivated, and they do great work.
Back.
This might be a bit rambly, so please bear with me. But if the kelp forests, the pressures on them, we're seeing the forest decimated in the 80s, what change is there to these pressures now that would give you confidence that the outplantings are going to be successful? Does that make sense?
No, awesome question. And yeah, absolutely reasonable. Why are we doing this? What's the point if basically it's a sinking ship, so to speak? So I call it the triple whammy of pressures. Increasing sea temperatures and particularly low nutrient waters. In Tasmania, it's the extension of the East Australian current has been a big issue, right? That's the kelp have suffered because of that, and as they've been lost, other seaweed species have moved in to fill the gaps. But you also have range expanding species like the long-spine sea urchin and the herring kale. These are herbivores, which have a big impact on giant kelp as well. They seem to preferentially feed on giant kelp. And similarly, when they've overgrazed, even if we can manage them, the competitive species come in to fill in the gap. So we're using the commercial community to do the management of the herbivores. For years, University of Tasmania has been paying for either targeted or take-all harvests of Centra stephanus, for example, and it really works. The underwater vegetation comes back, right? But now what we're paying them to do is a bit of underwater gardening, where they come in and literally garden. They cut out the weeds and they plant in what we want to grow. And what we want to grow has been sourced from populations which have survived these marine heat waves. We're not using anything that's genetically modified or anything like that. We've let nature do the selection process for us. But we're trying to get as much diversity into those populations as possible. So, for example, any sites south of Port Arthur area, the Tasman Peninsula, we've sourced the genetic material that we're using for those sites. We've sourced from 6 different populations. Remnant populations, existing populations, which otherwise wouldn't be mixing. There wouldn't be that genetic diversity in the population. And I mentioned CSIRO's work. They've recently mapped the reference genome for giant kelp, and we've supported them to create a biobank for genetic material and reproductive material sourced not only from Tasmania, but from the mainland as well. They have to this point, they have an incredible library of genetic material that we can pull from and try to get as much diversity into the populations as possible. So that's the best we can do at this point to get at each one of those different stressors independently, but in a way that hopefully will help recover giant kelp at some level. Does that answer your question?
Thanks, fellas. Great.
Yeah.